Let's get a full screen. So this is going to be a video about solving equations and maybe looking at some of the patterns that come from the processes that we're going to analyze in the next 10, 20 minutes. I don't have any prepared remarks. I just threw this up 10 seconds ago. I solve things a little differently in my classes than probably the typical approach. I don't allow subtract 11 from both sides. I'm sorry, that's not how we do things in this class. So our approach is as follows. First off, we have to establish the order of operations. So I will take 2 minutes here, and then we will do a variety of equations, hopefully very quickly. But I'm going to take a few minutes to talk about order of operations in math, which generally falls after parentheses, hardest operations to easiest, basically how we do things. So what do? We put a number in for x. We do the parentheses work. In this case, we multiply by 4. Okay, so we drop a number in, right? Get an x value, we drop it in, multiply by 4, subtract 7 cubed, multiply by 5, and then add 11. And that takes us to our destination, some kind of answer. Well, we know our answer in this case is 0. I didn't have to make it 0. I don't know why I made it 0, but I did. Maybe I'll make it some other number just to have it generic. Let's say it's 8. I don't have an 8 on the board, so let's say it's 8. What do I want to see in my class? I want to see the thought process. I want to see -3. I want to see -3/5. I want to see the cube root, which is negative cube root of 3/5. I want to see addition of 7. And the last thing I want to see is division by 4. So we got a negative cube root of 3/5 plus 7. And that's getting divided by 4. Now, there's a lot that took place there. I got a little rotator cuff problem, but try to line up the equal sign for organization. I can correct that more easily than if somebody shows me -11, -11. And I think there's a very subtle difference there. What I'm doing is inverse operations. All right, adding 11 became subtracting 11 from 8. Multiplying by 5 became division by 5. Cubing became cube rooting, knowing that cube root of a negative is a negative number. Subtracting 7 became addition of 7. Multiplying by 4 became division by 4. And then we're getting back to the x value we started from. That's what I'm hoping to see in my class. And then I'm hoping students will take their answers, occasionally take an answer and do one. Put it back to the original and just analyze it for a second. We got minus a cube root of 3/5. We've got addition of 7, and we got division by 4. And pretty much everything that took place is hiding in this answer. All right, but so the focus of this is, well, I'm sorry, I didn't really mean to give you 4x minus 7. I really meant to write e to the 4x minus 7 is what I meant to write. I'm sorry. That's a whole different equation. So let's solve that one. Let's see, what am I going to do? Oh, I think I'm going to subtract 11. I think I'm going to divide by 5. Oh, I don't think I'm going to take a cube root. I think I'm going to do the inverse of e, which is the ln. I can stop here on this particular problem because that's undefined. So this graph is never going to hit 8. Should have known that to begin with because the asymptote, right? We got exponential growth, excuse me. We've got exponential growth and the asymptote looked at the wrong thing. It's 11. Well, where's 8? 8's below 11. Does this graph ever intersect? No. And we don't use imaginaries in this context because imaginaries are all about, what squared gets us -1. All right. So I learned something there. I picked a very poor problem. So the inverse isn't gonna work. So what am I gonna do? I'm gonna change this now. I'm gonna make that a 1, so we have some answers. All right, and then we'll be able to do ln too. So I subtract 1, let's make it a 2, get some new numbers here. So I subtract 2, well, that's 6. I'm gonna divide by 5. Looks like I'm gonna do the inverse of E. ln of 6/5. I think I gotta add 7. And then I think I gotta divide by 4. And I got an answer. Wow. With the thought process. The inverse operations of evaluation. But I didn't mean to write E. No, I didn't mean to write that. I meant to write 3 to the 4x minus 7. That's what I really meant. So we gotta do this again. Yeah, guess we gotta do it again. I wonder how I solve this. Think I gotta subtract 2. Think I gotta undo the multiplication. You can see where my brain is and what I write. Now you know why I'm making careless errors in life. The inverse of 3 to the. Boy, I don't think we can solve these equations if we don't know that inverse operation. Well, that's log base 3 of. And then I guess I gotta add 7. I guess I gotta divide by 4. That's what we're practicing each and every day. Trying to get better. But I didn't mean to ask that. Sorry, wasn't what I was trying to ask. I really wanted the square root of 4x minus 7 in here. I need to solve that. I wonder what I'm going to do first. Think I'm going to subtract 2. Think I'm going to divide by 5. Think I'm going to do the inverse of squaring, which I think is inverse of square rooting, I think is squaring. I think I'm going to add 7. And I think I'm going to divide by 4. Yeah. But I'm sorry, it's not what I really wanted to ask. I really wanted log base 2 of 4x minus 7, and I wish I knew how to solve that. Wonder what the first step should be. Oh, why don't I subtract 2? Yeah, I think something plus 2 is 8. I guess that something would have to be 6. Something plus 2 is 8. Yeah, I guess that would be probably the thing to do. If I'm dividing by 5, if I'm multiplying by 5, then this thing probably should be 6/5. Yeah, I guess 6/5 makes sense. Of course, I erased that, right? So I guess I got to go backwards here through the process. You would think I would know what I wrote. I got a 2 there, I got a 5 there, and I think I said log base 2 of 4x minus 7. I think that brings us back. Okay, yep, 6/5, and I guess I need to know the inverse of log base 2. Well, that's 2 to the. Be nice if you understood the 5 was a 5th root to the 6th power. I guess I got to add 7. And I think I got to divide by 5. I already did that. I got to divide by 4. Sorry. You would think that my memory would serve me well enough from the previous problems, but it doesn't. Cognitive decline continues. I'm sorry, I didn't mean log base 2, I meant ln. Well, maybe we can cut to the chase and say, well, where do things change? I guess right here. Yeah, I guess right there. I guess I need to know the inverse of ln. Hope you say e to the. Very similar to 2 to the, except now it's 2.71 to the. And then I guess I got to add 7. E to the 6/5 plus 7. Then I guess I got to divide by 4. Well, I'm sorry, that's not what I really wanted to ask. I really wanted to ask f of 4x minus 7. Really wanted to ask that. Well, I guess I gotta subtract two. I think I can leave it to there. I think those seem to be the first steps. I guess I can shortcut this a little bit. And I gotta do the inverse of F. Oh. Oh, that's where I'm at. Oh, no kidding. And then I guess I gotta add 7. Then I think I gotta divide by 4. Wow. Boy, it seems like I'm studying processes here. Well, that's not really what I wanted to ask. I really wanted to ask f of g of x. Well, I think I got to this line of work pretty easily. Yeah. Yeah. Oh, boy. But I guess 6/5 is not 6/5 anymore. I think it's g of x. I guess I gotta add, well, no, I don't know. I don't see the 7 anymore. I don't see the 4. Oh, God. Oh, geez. F of g of x, that's still there. It used to be 4x minus 7, right? So this has gotta go. That's gotta go. So, yeah, boy, what am I doing now? And that's still f minus 1 of, this is still okay, right? So I'm f of, I'm still f of minus 1 of g of x. So I gotta do the inverse of g of x, which is, I think that's gonna be g minus 1 of f of g of x. My goodness. 6/5, but I still have the 6/5 here. So I still have that. So I butchered that. So that's still here. Right? You can tell I've never done this before, right? Never done this video before. So I'm doing it on the fly. And then I guess I got to do what? I guess I got to make this 6/5, so that is 6/5. And F inverse of 6/5, and then I got to do G inverse of that. And what's the inverse of when it was 4x minus 7? Well, if it was the inverse of this, I'd have to add 7 and then divide by 4. So I think I'm okay now. But I didn't tell you what that was, so I think I'm here on this problem. Well, it's the first time I've done that. What I like is repetition. So that'll be in the worksheet. So if I've said something improperly or done anything improperly, I'll catch it. Right? I'll catch it because we're going to keep repeating the process. And I hope that, by doing that, folks might get this thought process because it's a quick way to isolate X. All right, so let's just do a new one and let's see if you can zap off a correct answer. I'll just make a quick, what did I forget? I didn't do the sinusoids, so we could have done that, but is there something that I could ask quickly and easily? That could at least push us forward a little bit. I did ln, I did log e to the x, 2 to the x. Did I do 2 to the x, something like that? I think I did. Maybe I didn't. I don't know. Let's try to solve this. See if you can solve 7e to the 9x minus 2 over 8 plus 11 equals 50. All right, let's see if we can get a quick answer there. All right. You pause the video, you try. I'll just go down the line and see if I make a mistake. Okay, that's what I'm seeing. Okay, I wouldn't call this a user-friendly number. You want to approximate ln of 39 over 7? How many times is 7 going to 39? 5 to 6. ln of 5, that should be memorized, 1.6. ln of 8, well, ln of 6 we've done, right? ln of 6, 0.7 plus 1.1, roughly 1.8. So I didn't need that one. I don't know why I said that one. And the ln of 8 we just did in class, approximately 2.1. All right, so my answer of 39/7 is somewhere between these numbers. Times 8 plus 2 divided by 9 could give me a feel. Could give me a feel for the problem. Let's just say it's a 2. Let's just say it's a 2 for the heck of it. Instead of 2.1, let's call it just 2. Then I got 8. Did I put a plus here? Shouldn't have been there. It should have been 8 times, right? So that was a mistake. I'm glad I came back to this. Yasser would have got it. All right, so 16, 18 divided by 9. Yes, this number is somewhere around 2. We could put it in graph. We could graph that quickly and easily and see that appear. Maybe we should. All right, we have to make this number equal to what? 0. What makes it 0? 2/9. So I got y equals 11. I got exponential growth at 2/9. 2/9. I'm gonna get 0, which means this is 1. 7 plus 11 is 18. Right, at 2/9. When is this thing equal to 1.1? 8.8 plus 2, 10.8 divided by 9. 10.8 divided by 9, 10.8 divided by 9, a little bit bigger than 1. I'm just gonna estimate really quickly here. Let's call it 1.2. Just ballpark. That makes this 1.1 times 7, 7.7 plus 11. 7.7 plus 11, 18.8-ish. 18.8-ish. Going straight up. Does it look like we might hit a height of 50 at 2? Yeah, it's believable. All right, so just rough estimates. Okay, but this is what I wanted to highlight. Wanted to highlight that process. So I hope you followed, and I hope you made the connection that we're looking at. I guess I haven't done the final step here, but let's just look at kind of a basic process of a multiplication times a major function plus c equals some number. What have we been doing? We've been getting rid of the constant, we've been dividing by the multiplier, and then we're hitting the major operation. And then if there's more to deal with inside the parentheses, then we go from there. Okay, I hope I didn't make a mistake with the f-1 and g-1, but I've been tending to make more careless errors as I'm talking. Because I don't prepare anything, I just go on the fly here. But I hope that helps someone. I'm not a big scale of justice fan. What you do to one side of the equation, to do the other. I'm not a fan of that approach for solving equations. I think you run into trouble when I ask, okay, you're doing sine on this side, what's the inverse? Not used to talking in those ways. Used to adding and subtracting, multiplying and dividing both sides, but talking about the inverse operations of a function is where things have to be highlighted. And that's in my opinion, as Joshua would say, in my humble opinion. And I do believe that he has a lot of humility, so we can accept that. All right, stay safe, stay warm.